and start sharing the screen. And let me go to the outline that I started for today's notes. So homework 32 is due next class. I believe that that's the assignment on simplifying fractions, simplifying rational expressions, the definition of rational expressions, remembering that they're undefined when the denominator is 0. 33 and 34 are what we're going to look at today: multiplying, dividing, adding, and subtracting those algebraic fractions. 35 and 36 are radicals, square roots, simplifying square roots, evaluating square roots. Then problem set 5 is that practice test for exam 5. Those will be due on the 10th. Test 5 will be available after the 10th. Let me just pull up my calendar here. The 10th is that Thursday of class, so it'll probably be available from the 10th to the 13th. I'm sorry, the test will be the 10th to the 13th. The preliminary final will be due the 17th. We'll go over that on the 15th. And the final exam will be available for you to take between 8 a.m. and 8 p.m. on the 17th. Realize, folks, that this is a different time than all of the other tests have been. You're going to have it shorter access to the final exam than you've had to the other tests because there's a quicker turnaround where I have to be turning your averages to the college. If that time frame does not work for anybody, let me know either after class or send me an email. I can work with you a little bit, but I do have to have everything graded and submitted to the college by a certain date. So I can't give you time late, too much later than that to take the final exam. Does anybody have any questions about any of those dates that are coming up? If not, have you folks started looking at that homework 32 on simplifying rational expressions? Does anybody want to look at any of those homework problems? No questions? If not, I'd like to start with a question kind of based on what we had done in the past. A quick review. Let's say we have the rational expression 2x squared minus 8 over 4x minus 8. And I want to ask you to do two things. One is to find any numbers for which the expression is undefined. And then after you do that, I want you to simplify the expression. So, oh boy, can anybody refresh my memory on how to find numbers for which the expression is undefined? Can anybody help me find where the expression is undefined? What do I do? Nobody? Can you guys hear me?
equals 0.
So it's where the denominator equals 0. So my denominator would be 4x minus 8. And so I've got to find what values make that equal to 0. So can everybody take a second and solve that equation for me and tell me what you got? Anybody have an answer? Is anybody getting it's undefined when x equals 2? Everybody okay?
Could you show me that, please?
So you've got 4x minus 8 equals 0. To solve that, first we'll add 8 to both sides, which gives me 4x equals 8. And then to finish getting x all alone, we have to divide by the 4, which brings us to x equals 2. Better?
Yep, perfect.
And then I'm going to rewrite the expression. We've got 2x squared minus 8 over 4x minus 8. And we want to now simplify the expression. Can anybody remember what you have to do first to simplify a rational expression? Everybody remember fractions are fun if you factor first. And so first let's factor the numerator. When we factor, we always look for a common factor to start with. Is there a common factor between 2x squared and negative 8?
Two.
Beautiful. And so when I divide out the 2, I'm left with x squared minus 4. And now can I factor that x squared minus 4? Oh, I've got two terms. There's a minus sign in, whoops, there's a minus sign, not an equal sign in between. And they're both squares. So do you remember it becomes x plus 2, x minus 2, the sum and difference. Now that the numerator is factored all the way, let's factor the denominator. Between 4x and 8, is there a common factor? Four. And when we divide that out, we're left with x minus 2. And I don't think that factors any further. So that gives me 4 times x minus 2. Now that we've factored, we can have some fun canceling, crossing things out. Are there any factors common between the numerator and the denominator?
X minus 2.
X minus 2, so we can divide them both by x minus 2. So right now that leaves me with 2 times x plus 2 over 4. And then with the numeric part, does everybody see that I can reduce the 2 over 4? Dividing out 2, 2 divided by 2 is 1. 4 divided by 2 is 2. And so my final answer will be x plus 2 over 2. And that was what we had been looking at last class. Let's look at, another one. This is sort of a fun one. It's a little bit different. Let's simplify. Let's look at x squared plus xy plus 2x plus 2y over x plus 2. Again, in order to simplify, we have to factor first. So off to the side on scrap paper, I'd like to factor that numerator, x squared plus xy plus 2x plus 2y. I notice that this one has 4 terms. Can anybody remind me how to factor when there are 4 terms?
Split it down the middle.
Split it down the middle. Beautiful. And so now when I split it down the middle, what do the first 2 have in common?
X.
And when we take that out, we're left with x plus y. And then what do the last 2 have in common?
2.
2. And because it's a plus, we had a positive 2. And when we divide them by 2, we're also left with x plus y. So factoring, one factor is x plus y. And when I divide that factor out, I'm left with what remains, x plus a 2. So that gives me x plus y times x plus 2 in factored form over x plus 2. Now, is there anything common between the numerator and the denominator?
X plus 2.
Beautiful. And when I divide those out, my final answer is just x plus y. And then let's do one last one. Let's simplify. Uh, 49 minus y squared over y minus 7. And so how would that 49 minus y squared?
The top is 2 squares.
It's the difference of 2 squares. Beautiful. And so that'll leave me with 7 minus y and 7 plus y. And we get over y minus 7. Now, there aren't any factors that match up exactly, but as I look at this, the 7 minus y and the y minus 7 are real close, aren't they? It's just that the subtraction is reversed. And does everybody remember last class? We ended by saying that if the subtraction part of me is reversed, they can cancel, but they cancel to -1. And so my final answer would be the negative of 7 plus y.
I remember, but why does that cancel to -1?
Because they're opposites. If I look at 7 minus y, if I were to take that and multiply it by -1, I would get -7 plus y, which would be your y minus 7. So that 7 minus y is -1 times y minus 7. They're opposites. And so opposites will always cancel to -1 because one is a -1 times the other. Does that help?
Yep.
So, but that's all right. We spent a lot of time last class developing those concepts. Today we're going to take them a little bit further, and we're going to look at first multiplication, then division of rational expressions. So let's start by looking at multiplying rational expressions. And in terms of multiplying rational expressions, I want to just look at multiplying two fractions. Let's say, for example, I have something like 2/3 times 5/7. Does anybody remember what you need to do to multiply two numeric fractions? Do you remember you take the product of the numerators and put it over the product of the denominators? And so that'll give me 10/21. In general, if I multiply A over B times C over D, I multiply the numerators and I multiply the denominators. It's the product of the numerators over the product of the denominators. And so when I'm multiplying two rational expressions, I just multiply straight across. Numerator times numerator, denominator times denominator. But then we have to simplify. And we're going to find that with these rational expressions, if we start simplifying at the beginning, it makes our lives easier. So with these, the first thing that I want to do is factor each numerator and denominator completely. Then I'm going to multiply, and I'm putting that in quotes, numerator times numerator over denominator times denominator. And then I'm going to simplify if possible. And again, I always think of it as a silly sentence. Fractions are fun if you factor first. The fun part is the crossing out. In order to be able to do that, you have to first be able to factor. So, there's the rules. Let's look at a couple of examples. So first example, let's multiply. And let's look at x plus 2 over x minus 4 times 3x minus 12 over x squared minus 4. And so what we're going to do is we're going to factor each numerator and each denominator. So if I look at that x plus 2, there's nothing in common and there's no exponents. So that part I won't factor. I'll leave it as x plus 2. In the same way, x minus 4, there is nothing in common and there are no exponents. So I'll leave that as x minus 4. Now I'm going to look at this next numerator, 3x minus 12. Is there anything in common there? Common
3.
3. And we'll have left x minus 4. That numerator factors into 3 times parentheses x minus 4. And now how about that denominator? How would you factor x squared minus 4? Okay. Difference of squares.
2 squares, yeah.
So it'll be x plus 2 times x minus 2. And so I factored everything. Now that second step, multiplying, I did that because what I did was I took the two fractions, and you see how I just turned them all into one fraction? Everything from the numerator is being multiplied in the numerator. Everything from the denominators is being multiplied in the denominators. So that multiply step really is just writing all of the numerator factors in a single numerator, and all of the denominators factors in a single denominator. I don't want to multiply it out yet, because if I were to multiply those numerators and denominators out, I'd have to work pretty gosh darn hard to reduce it. By multiplying them in factored form, does everybody see that since it's already factored, I can reduce now? Is there anything common to the numerator and the denominator?
The x plus 2 and the x minus 4.
They both have an x plus 2. I can divide it out. Beautiful. They both have an x minus 4. And so my final answer is 3 over minus 2. And so when I look at these multiplying rational expressions, I really don't think it's a heck of a lot different than simplifying them. It's just we're doing two fractions at once. And again, the idea that fractions are fun if you factor first. You have to factor before you can do the fun part, crossing those common factors out. Let's look at another example. Let's look at 3x plus 6 over 14 times 7x squared over x cubed plus 2x squared. I'm going to be quiet for a minute and ask you folks to factor the numerators and denominators as much as possible. Can we go over, or do you want me to wait a minute more?
I got sort of something.
First numerator, did everybody see there's a common factor of 3, leaving me with 3 times x plus 2. 14, I'm going to leave b. 7x squared, I'm going to leave b. And then this x cubed plus 2x squared, they both have x's. The lowest exponent is 2, so I have a common factor of x squared. And when I divide that out, I'm left with x plus 2. Just the factoring part. Are we okay or not?
The only thing I did wrong is in the bottom, I put x times x squared plus 2. I was
Look for
messed
the
up on that.
thing you can take out. If that variable shows twice, always pull out the lowest exponent so that we could take out the x squared, the x. And taking out the x squared, you notice that now we can have a heck of a lot of fun because I can cancel out the x plus 2s. I can cancel out the x squareds. And then depending on how comfortable you are with number fractions, because that's all that's left, we can either just multiply and get 21 over 14, which we can reduce by 7 to get 3/2. Or when it's in this form, we can divide 7 by 7 to get 1s and 14 by 7 to get 2, which would take me directly to that 3/2 either way. And once we've got it multiplied and reduced, doesn't it look a lot better than what we started with? Let's try another one. Did I turn the page too fast? Was everybody all right with that one?
Yep.
Then next one, I got 4x plus 8 over 7x squared minus 14x times 3x squared minus 5x minus 2 over 9x squared minus 1. Lots of factoring here. These multiplication problems actually turn out to be like 4 of those factoring, up to 4 of those factoring problems that we had last unit. So I'm going to wait a minute for everybody to factor. How are we doing?
I just had trouble with the top one, but
Okay.
okay.
I don't know if you noticed the order in which I did it, but honestly, when I do these, that top one I do think is the most involved to factor. So I did it last. First fraction, we've got common factors, a common factor of 4, 4 times x plus 2. Denominator, we have a common factor of 7x, 7x times x minus 2. Then I looked at this denominator, 9x squared minus 1, and I see two terms with a minus sign. So I see it as the difference of squares, 3x plus 1, 3x minus 1. And I'm going to erase this numerator for a second. Up until there, this is factoring all right for everybody straightforward.
Yep.
Factor that numerator. I know that the first two have to multiply to 3x squared. So that's going to give me 3x and x. I know that the second have to multiply to 2. Now, it doesn't always work that way, but a lot of times with these, we hope things cancel out. And so I know that 2 can only be 1 times 2. And so I'm looking at this denominator. I'm seeing the 3x's and the 1's. So I'm going to try putting the 1 there and the 2 there, taking my hint from the denominator. And so now when I think of FOILing this out, first would be 3x squared. Outer would be 6x and 1x. And so then I thought, well, if I put the negative here, it would be minus 6 plus 1, which would give me the negative 5x in the middle. And so I factor the ones that are easiest first, and then I look for clues from those to help me factor the harder ones. Does that make sense?
Yep.
So now, the other thing that's cool that happens is the way that factored, we have a lot in common. The x minus 2's and the 3x plus 1's. And so I'm left with 4 times x plus 2 over 7x times 3x minus 1. And a lot of times with these, you're fine stopping there. A lot of times the directions will let you leave the result in factored form. All right?
Yep.
Let's try another. This time, let's look at 12x minus 3x squared over 6 times 9 over 2x minus 8. And again, I'm going to be quiet and let you folks factor it. Let me know when you have it, when you think you have it. Are we ready to go over, or do you want for me to wait another minute?
I'm ready.
You ready? Okay, first numerator, there's a common factor of 3x. And we divide 12x by 3x, we get 4. When we divide that 3x squared by 3x, we get x. We've got 4 minus x. I'm going to leave the 6 alone. Then I have 9 times, in that denominator, there's a common factor of 2. And I'm left with x minus 4. Now here, the 4 minus x and the x minus 4, they're both subtraction, but it's reversed. So remember, we had said that we can cancel those as long as we remember to multiply our answer by -1. Otherwise, let's see, I can put 3 into 6 twice. And so I'm left with, in the numerator, 9 times x. In the denominator, 2 times 2 is 4. But I have to remember that that whole gosh darn thing is negative. We good?
Yep, I just want to write it down.
Okay. Let's look at a couple more. Next, let's look at x over 5x minus 10 times x squared minus 2x over 4. And again, whenever I see this multiplication of rational expressions, I immediately think that what I'm really doing is factoring a lot and then hoping that things match up. Again, I'll give you a minute or two to work on this one. Ready?
Yep,
First numerator is just x. First denominator, there's a common factor of 5, leaving me with x minus 2. Second numerator, there's a common factor of x, and I've got x minus 2. Second denominator is just 4. Common factors, just the x minus 2. And when I multiply across, I'm left with x squared over 20. Everybody happy with that one? If so, to multiply, we have to factor. But now that we know how to multiply, the next thing that we're going to do is divide. Because I don't know if you folks remember, the rules for dividing fractions is don't. In order to divide, we change it into a multiplication problem. If I look at the division of rational expressions, let's start with a numeric example. Let's start with something like 9/4 divided by 21/10. Does anybody remember, in order to divide fractions, you might have heard the expression keep, change, flip? The first thing that you do is you rewrite it as a multiplication problem. In order to do that, you keep the first fraction the same. That'll stay 9/4. You change the division to multiplication. And then you flip or take the reciprocal of the second fraction. How do you spell second? Oh boy, I missed a letter there. So the reciprocal of 21/10 would be 10/21. Now that we've rewritten it as a multiplication problem, we're going to multiply and simplify. Here, the way in which you multiply with numbers, I guess, depends on your personal preference. I'm going to do this one of two ways. One way, we could just multiply across, take 9 times 10 over 4 times 21, which would give me 90/84, and then reduce. Let's see, to reduce, we could divide them both by 2, which would give me 45/42. And then we can divide those both by 3 and get 15/14. Or, I don't know, I know a lot of students aren't as comfortable with this method as I am, but I grew up in pre-calculator days. And so in pre-calculator days, we always tried to keep the numbers small. And so when I look diagonally, 9 has a factor of 3. I can divide it out and get 3. 21 has a factor of 3. I can divide it out and get 7. I can divide 4 by 2 and get 2. I can divide 10 by 2 and get 5. And that leaves me with the 15/14. Which way is the best? The way you can remember, the way you can understand, the way you're less likely to make a careless mistake. I know people of my generation, it was easiest to divide out those common factors like we do with algebraic fractions before we multiply. But I know usually students like you guys have it easier first multiplying and then reducing. Either way, it takes you to the same place, so it doesn't make a difference. But what's key here is that we remember that the rule for division is we don't divide. We take that division problem and rewrite it as a multiplication problem using what you might remember having heard before. Keep the first one, change the division to multiplication, and take the reciprocal of the second. To divide fractions, we're going to multiply by the reciprocal. And we're going to see that we do the exact same thing with algebraic fractions. And so let's start with a pretty straightforward example. Let's have 7x squared over 6 divided by x over 24. And again, the first thing that I want to do is rewrite it. The first fraction I keep, it stays the same. I change the division to multiplication, and I take the reciprocal of the second, and now it's a matter of personal preference whether you multiply across or divide out common factors. I'm going to divide out common factors. 6 goes into 6 once. 6 goes into 24 4 times. Then x goes into x once. X goes into x squared x times. And so that leaves me with 7x times 4, or 28x over 1 times 1, or 1. So my final answer is just 28x. And again, if you're not comfortable with the way in which I reduced those, the other option, once we have it rewritten as a division problem, a multiplication problem, pardon me, is to just multiply. Let's see, 7 times 24 is 168 x squared. And then we can divide 6 into 168 would be 28. X into x squared would be x. Again, both take us to the same place. Questions on that one?
No.
Then let's look at some that are slightly more challenging. Next example, let's take x squared minus 8x plus 16 over 6 divided by 3x minus 12 over 2. And again, it's a division problem. The first thing I say to myself is self, we don't divide. We change it into a multiplication problem. We leave that first fraction the same. We change the division into multiplication, pardon me. And then we take the reciprocal of the second fraction, or we flip it. Make sure you copy it right when you do that. That 6 should be a 16. Sorry, folks. Now, in order to multiply, we have to factor everything completely. X squared minus 8x plus 16. That should factor. X squared will be x times x. Because it's a positive 16, I know my signs are the same, both minuses. And let's see, multiply to 16, add to 8, I think would be 4 and 4. We'll have the 6. We'll leave the 2. And then 3x minus 12. There's a common factor of 3. When we divide that out, we'll be left with x minus 4. Now, Anything common between the numerator and denominator? We can divide out the x minus 4. Technically, we're dividing it out, although in practice, it looks like we're just crossing it out. And I look at this 2, and I see it as a common factor with the 6. So 2 divided by 2 is 1. 6 divided by 2 is 3. And so now when I multiply across, in the numerator, I'm left with x minus 4. In the denominator, I have 3 times 3 or 9. Is that one all right?
Yep.
So let's get a little bit more challenging. This time I'm going to shut up for a couple minutes and let you guys factor away. This example, I'm going to have 3 minus x over x squared plus 6x plus 5 divided by x squared minus 7x plus 12 over 2x plus 10. Again, I look at that initially as potentially 4 factoring problems before I begin. But first, you want to rewrite it as a multiplication.
Okay.
Ready?
Yep.
So first, I'm going to rewrite it. First one stays the same. The division becomes multiplication, and I take the reciprocal of the second one. Then I factor what I can. 3 minus x does not factor. Next, let's see, I'm going to go sideways. 2x plus 10, there's a common factor of 2, giving me x plus 5. Then, where I have x squared plus 6x plus 5, x squared can only be x times x. 5 can only be 1 times 5. Signs are the same, both positive. And then with the x squared minus 7x plus 12, let's see, x squared can only be x times x. Signs are the same, both negative. 12 can be 1 times 12, which won't give me a 7. 2 times 6, which won't give me a 7. But 3 times 4 will. Again, if you're not comfortable with your factoring, off to the side to check it. Check it by multiplying them out. Now that we've done the hard work of factoring, we can do the fun part. Kind of reminds me of an old-fashioned game show that used to be on television where you had to remember where things matched. It was called concentration. Call it matchy-matchy game, I guess. These match, so they're out of there. Oh, these two don't exactly match, but they're close, they're reversed. Remember, reverse subtraction can be canceled if I remember that that makes my result negative. And so my final answer is a negative fraction. In the numerator, I'm left with 2. And in the denominator, I'm left with x plus 1 times x minus 4. That one all right?
Yep.
Good.
Just, how come, I guess, can you just remind me why the x minus 3 and x minus 4? I thought it was going to be x minus 3 and, or x plus 3 and x minus 4 to make negative 7,
Let's-
but
X plus 3 times x minus 4. Let's check it. First, x times x is x squared. Outer, x times minus 4 is minus 4x. Inner, x times positive 3 is plus 3x. Last, positive 3 times negative 4 is negative 12. And so, first of all, because these guys have different signs, do you see how that gives you a negative 12? And we wanted a positive 12. And secondly, with the different signs, do you see how it gives you minus 4 plus 3? That would add to negative 1, not 7.
yep.
So instead, because this is a positive, whenever that last term is positive, it tells me that my two binomials have to have the same signs. And when they have the same signs, it will always be the same as the middle sign.
Okay, that's what I meant. Thank you.
Right. Thank you for asking. All right, then let's look at one more. Let's look at 3x to the 7th over 7x to the 5th. Divide.
Professor,
Yeah?
I don't mean to interrupt, but I have work kind of early today, so I was gonna leave like the Zoom meeting a little early if that's okay, but I didn't want to just like exit out without telling you.
Okay, please realize that class is recorded, so I hope you take the time to listen to the part that you missed. And
Yeah.
the notes are uploaded. Have you been able to read the notes that I uploaded into Blackboard?
Yeah.
Over what you missed, okay?
Yeah.
All right. Okay, see
Okay.
you on Thursday.
Okay, have a good day.
Sure. So we've got 3x to the 7th over 7x to the 5th, and I want to divide it by 6x over 35x to the 3rd. Let's keep, change, and to take the reciprocal. And now from here, what you do is a matter of personal preference. Would you folks want to, because they're all single terms, just multiply across and then reduce? Or did you want to divide out common factors first? What would you folks do?
I divide out the common factors first.
So common factors, 7 goes into 35 5 times. X to the third goes into x to the fifth, x squared times. X squared goes into x to the seventh, x to the fifth times. X goes into x to the fifth, x to the fourth times. Oh my God. In the denominator, everything's crossed out, so we're left with 1. In the numerator, 3 times 5 is 15, and then we've got that x to the fourth. I also know that there are some students that look at that and it's too much crossing out for them. So let's go through and also do this one the other way.
I just ask you a quick question.
Sure.
Is to the common factor between the 7 and the 35, it's not 7x cubed?
Oh, you could take out the 7x cubed at the same time. Sure. I did it
Okay.
in grabs. You can do it all at once.
Okay.
And I'm impressed that you saw it that way. I like it. So that what you're did is you're see that
And then would that leave me with x squared in the bottom on the
when
first
you
one?
it would leave you with 5 here and x squared here, and that's beautiful.
Okay.
So the other way, if we just multiplied across, 3 times 35 is 105x to the 10th over 7x to the 6th. And then 105 divided by 7 would be 15. X to the 10th divided by x to the 6th would be x to the 4th. They both take you to exactly the same place. So we can multiply these things. And if we can multiply them, we can divide them. What we haven't done yet is add and subtract them. And next semester, if and when you take that Math 110, you're going to find that if I'm looking at adding and subtracting general rational expressions, they involve a lot of work. However, because this is considered a foundations class, we're not going to go into those more involved problems, but we're going to restrict our thoughts to one type of problem. So let's start by just looking at the idea of adding and subtracting rational expressions. And I want to think of fractions first. If I have 1/2 plus 1/4, we'll start with a pretty simple fraction problem. Can anybody remember what we need to have in order to add or subtract fractions?
No.
Do you remember that they must have a common denominator? So that 1/2, if we multiply top and bottom by 2, and I like writing it this way because it shows me I'm just multiplying by the number 1. So I'm not changing the value, just the way it looks. And so that gives me 2/4 plus 1/4. And once they have the common denominator, in order to add them, I'm going to keep that as the denominator. So the denominator of my answer will be 4. And then I add if it's an addition problem, or subtract if it's a subtraction problem, the numerators. And then I simplify if possible. And in this course, we will only be looking at fractions that already have that common denominator, because it's when they don't have that common denominator that we've got to do a lot more work. So this semester, we're only going to look at those fractions that do have a common denominator. So let's look at some examples. Let's look at 8x over 3y plus x over 3y. And again, I have to make sure that they have the common denominator. And if they have the common denominator, I'm going to keep that denominator. So they both have a denominator of 3y. I'm going to keep that denominator of 3y. And then here, because it's an addition problem, I'll add the numerators. So 8x plus 1x is 9x. And then, if possible, I'll simplify. And now here, in terms of simplification, I've got that common factor of 3. And so when I divide by 3, I'm left with 3x over y. That one all right with everybody?
Yep.
So let's look at some more. Let's look at 3x over 3x minus 7 minus 7 over 3x minus 7. And they've got the same denominator. So that's going to be the initial denominator of my difference. This is subtraction. So my numerator will be the difference, 3x minus 7. And now that I've subtracted, does everybody see the numerator and the denominator are common? And so that'll divide out to 1. Let's look at a couple more. Next one's a little bit more challenging. Next one, I've got 2x squared plus 5x over x plus 2 minus 4x plus 6 over x plus 2. And what makes this one challenging is that I've got subtraction and I'll be subtracting a polynomial. And when I'm subtracting a polynomial, I know it's a little bit more writing, but I think that if we rewrite this before we do the subtraction, it will keep us from making careless mistakes. What do I mean by rewrite this? It's got the common denominator. I'll keep it. And then in order to subtract the numerators, because again, I am subtracting and I've got two polynomials, I'm going to rewrite it as showing the difference of the numerators. Does everybody see? I just kind of took that subtraction for the numerators and showed it. But because I put those parentheses around to show I'm subtracting, does everybody remember that in order to do a subtraction like this, the first binomial will stay the same? Do you remember when I have more than one term behind the subtraction, I have to kind of think of distributing that -1? And that gives me minus 4x minus 6. And you have to be careful when you do that. Now combining, we have 2x squared plus x minus 6 over x plus 2. And then to see if it can simplify, I'm going to try to factor just like the very first day we did these rational expressions. We started with problems like this, and in order to simplify them, we had a factor. That denominator does not factor x plus 2. To get 2x squared, it'll be x, 2x times x. My signs are different. One's a plus, one's a minus. In order to get 6, well, that 6, that -6, could be 1 times 6 or 2 times 3. And I need different signs. And this is one time where I do a little bit of cheater thought. Doesn't always work that way, but I'm looking at that denominator. And so I know the signs have to be different. If I make that a +2 and a -3, and I put the 2 in here and the 3 in here, it would be nice because things would be reducible. But again, because we're doing a little bit of that trial and error, that guess and check, I'm going to check by foiling. First, 2x times x is 2x squared. Outer, 2x times 2 is 4x. Inner, minus 3 times x is minus 3x. Last, minus 3 times +2 is minus 6. And you notice those middle terms do give me that 1x. So I factored correctly. And in factoring correctly, I did get that common term, that common factor, pardon me. And so my final answer is 2x minus 3. So again, be careful when you factor. That's why we had to do the factoring before we did the fractions. But I also think seeing the factoring used in the fractions makes it a little bit easier. And also, not gonna lie, I'm not above looking at the other factors in the problems for hints. How is that one?
Okay.
Try
Not bad.
one or two more. Next example, I'm gonna shut up and have you folks look at 16 over x minus 2 minus 8x over x minus 2. And I'm going to be quiet and let you do those. I'll give you a couple minutes. Did anybody else get -8 for a final answer?
No, but I almost did, but could you just show me, I know I have to, the x minus 2 and the 2x.
Yep. Did you
I know it's multiplied by -1, but
get the 16 minus 8x over the x minus 2?
yep,
Did you get the common factor of 8?
yep.
And so then did you cancel the 2 minus x and the x minus 2? And remember that that makes the fraction negative, multiply by -1.
Oh, it just makes it negative. I don't have to like I can just cross those out. I don't have to multiply that by -1.
And
It just
yeah.
makes my answer. Okay.
all right.
Yep.
So, how are you folks feeling about these fractions? We've got about a little over 15 minutes left. Did you want to do more together, adding, subtracting, multiplying, and dividing? Did you want to look at some from any of the homework? Or did you want to call it a day?
Are there any that you think are tricky or trip us up or not? Or have you kind of showed us those?
I think we've kind of looked at
Okay.
a lot of
Yep.
them. We try a couple more. Oh, you know what? I'm pulling out an old textbook and looking at a couple. Let's look at fun multiplication one. Yeah, and then let's look at let's look at a fun division one and a fun subtraction one, and then we'll call it a day. 2 examples. The subtraction one is going to be x squared over x minus 6 minus 5 plus 6 over x minus 6. And the division is, oh, what the heck? Let's look at x cubed plus 7x squared over x cubed minus x squared divided by 5x squared plus 36x plus 7 over 9x squared minus 1. Don't those look fun?
No,
I'm gonna be quiet for, I'll give you like 5 minutes to finish the two of them and then we'll go over them.
yep.
Right.
And that second one is the first bottom factored x. Oh, wait, never mind.
Rewrote it. Then
I had it wrong.
numerator, there's an x squared in the denominator, there's an x squared in common. The next numerator is the difference of squares. And then I'm looking at this denominator and I'm trying to figure out how to factor it. And I know that one of the factors we have to end with a +7. So I cheated. I looked over here. I thought, well, I bet x + 7 is going to be a factor. And then in order to get the 5x squared, it would be 5x + 1. And it works. How'd you cook?
Okay. I did okay. Just didn't get that 5x squared factor. But I almost did it.
I look at that 5x squared plus 36x plus 7. In order to do it, we've got a couple of ways. We could use that AC method, right? So that
Yep.
would be 5 times 7 is 35. Multiply to 35, add to 36. 1 times 35. And so that would give me 5x squared plus x plus 35x plus 7. Or 5x plus 1 plus 7 times 5x plus 1 will give us the x plus 7 times 5x plus 1. I think most people like the AC method. I'm old school. I've always been a big fan instead of the trial and error method, which we didn't do too much. But to get 5x squared, I've only got 5x times x. To get 7, I've only got 1 times 7. Signs are the same, but positive. And in order to get that 36 in the middle, I want to put the 7 in the other parentheses so that when I FOIL it out, they get multiplied by each other. So either way, though, it takes us to the same place.
Yep.
How are you guys feeling about these fractions? Is that enough for one day?
Yeah.
Yeah.
Not hard, just remembering, the whole process.
And honestly, the whole process